All right, hello, my name is Brandon Clayton, the Algebra Guy. Today, as you see on your screen, we will be discussing finding the least common denominator in creating equivalent fractions. The least common denominator in equivalent fractions. So by the end of this lesson, you'll be able to work problems similar to the one you see right here. Find the LCD, or the least common denominator, for the following fractions: 7/12 and 5/18. What's the least common denominator and what does that mean? So let's get into it now. As usual, let's start with our questions for this lesson. What is meant by the least common denominator? What is that all about? Maybe you've heard it, maybe you haven't, but let's dispel whatever's behind that now. Given two fractions, how can we find the least common denominator? The least common denominator. And how do we create equivalent fractions using the least common denominator? And why do we need equivalent fractions? I'm try to remember to mention that in our lesson for today. So let's get to it. All right, so I explained earlier in our lesson how to add and subtract fractions with a common denominator. But how can we add and subtract fractions with unlike denominators? Well, first let's think about it. Before we get into adding and subtracting with unlike, we need to understand least common denominator and trying to get those the same. So let me give you an example. So let's go back to our example with these coins. Can you add one coin and one dime? Well, I'm hoping you say yes. But if you look at them as a fraction, can you still add them? Because we know what they equal just using our money math. We know how to do that. Let me go back to my slide here. Take this thing off. All right, so we know how to do that in our heads and just using money math. But we talked about how a quarter was 1/4. And if we had two more quarters, that would be 2/4. So we had 1/4 plus 2/4 is just 3/4, because $1 divided into 4 is 1/4, which is 0.25. And 2/4 is two of those quarters, 1/4 and 1/4, is going to give me 0.5 as a decimal, and this would be 0.75. So hopefully that makes sense. But how do you do that as a fraction using a dime? Because a dime is taking that dollar and dividing it into 10 pieces, and each piece is worth 1/10 or 0.1. So if I were to write this out as a fraction, we'll end up with 1/4 plus 1/10. Now what do I do? How do I add these two together? What is 1/4 plus 1/10? And oh boy, you will get that fraction. And if you don't know, stay tuned. In here just a few minutes, we're going to talk about how to get this started so we can start to solve this. But our tendency may to be just to add, as we've done before, and go 1 plus 1 is 2. 4 plus 10 is 14. And we can reduce that by dividing both by 2 and get 1/7. But 1/7 is not equal. That does not give us the correct decimal of 25 cents plus 10 cents, because we know that that's 35 cents. And this is not going to equal 35 cents, because 35 cents is going to be closer to something like 1/3. This 1/7 is going to be, what is that, 1 divided by 7 goes in there 10 times, 7, 3, 7 goes to 30, 4 times. So you're going to end up with something like that. So 0.1, 7 divided, 0.14. So that's not 0.35. So that's not going to work. So we're going to have to come up with something else that can work. Oh, this is 1, 7. No, you know what? I did this backwards. I just realized that. I should have said 7 divided by 10. Thank you for being patient with me there. I'm like, why is it giving me 1 point? It can't be. So 10 goes into here. That can't happen, so that gives me a 0. I'm going to have to make a 0 here. It's going to be a decimal. So 7. 10 goes into 71. Oh, man, I'm still messing it up. 1 divided by 7. Where am I getting these numbers from? So 7 can't go into 1, so we have to add another 0. And there's a decimal. 7 goes into 10 one time. 1 times 7. Okay, I did do that right. All right. So I just need to put my decimal in the right spot. So that'd be 0.14, just like I did over here. So, hey, double guessing myself, but there we go. So, but the point is, these two are not going to equal. 0.35 does not give us the same thing when we just try to add. Because remember, in order to add, our denominators needed to be the same. 4 and 10 aren't the same. That's why we're not getting the right answer. So we need to talk about how do we get the same denominators, and that's going to lead us into our discussion about least common multiples. So what is the least common multiple? Least common denominator. Least common denominator of two fractions is the least common multiple of their denominator. So what does that all mean? So let's get an example up here to cut through all this jargon and talk about least common multiple, denominator, and such. So in order, let's say I wanted to get both of these to have the same denominator. Not two and three I can't add together. I can't do anything with that. What if I wanted to find the least common denominator between them? Well, what's the smallest multiple between each one of these? So let's start with 2. Let's do the multiples of 2. 2, 4, 6, 8, 10, 12, 14, and 16, 18, 20. So there we go. And what if I did the multiples of 3? So the multiples of 3 would be 3, 6, 9, 12, 3 times, what is that, 15, 18, 3 times 7 is 21, 3 times 8 is 24, 27, 30, so on. So now we look at both of these and we ask ourselves, what is the least common denominator? Which is another way of asking, what's the least common multiple? Well, let's circle common multiples that we find. Do you notice they both have a 6 in common? They also both have a 12 in common, and they both have a 18 in common. Now, we can keep on going forever, and they're going to have infinite number of multiples in common. But we're not concerned about any multiple. We're concerned about the least common multiple. So the smallest multiple they have in common is a 6. So if I were looking for the least common multiple between 2 and 3, it'd be a 6. And so in order to rewrite this, actually I'm getting a little bit ahead of myself. I'm going to go ahead and give you a teaser of what I'm about to get into. So instead of 1/2, I want a 6 in the bottom. Well, in order to get a 6 in the bottom, I'm going to have to multiply something to get to that 6. That's a 3. Well, since these are equal, I should be able to do the same thing on the top. 1 times 3 is 3. So 3/6 is now equivalent to 1/2. Same thing here. I want a 6 on the bottom. And we can say that this is going to be multiplied by 2 to get that. And multiply by 2 on the top to get 2/6. So now I can see that 3/6 is the same as 1/2. 2/6 is the same as 1/3. So if I wanted to add these or subtract them, instead of using 1/2 and 1/3, what could I use? 3/6 and 2/6. Why would I want to do that? Because now I'm able to combine these appropriately, right? So now I'm able to say this is the same thing as 2 plus 3/6, which is 5/6. So that's where we're going with this, and that's why that's important. So let's find the least common denominator for these fractions. We got 12 and 18. Well, we could employ the same method we just did a second ago, which was take all the multiples of 12 and just keep going. 48. What's that? 5, 60, 70, and so on, right? Dot, dot, dot. And we could do the same thing for 18. 18, 36. I don't know what the next one is. I think it's 40. Let's see, 3, 40. That's 18 times 3, 4, 54. So we can keep on going, dot, 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 and look for the least common multiple. Wow, we can already see it right here, actually. Look. I didn't see that. So just with a couple. But what if you have big numbers like this and it wasn't that easy to find within the first 2 or 3? You really don't want to write all this out and try to find out what those two numbers are. So let me show you a way. I'm going to keep this up here because this worked out pretty nicely, where I was able to find it within the first 2 or 3 multiples. But what if it's not that simple? You had two kind of funky looking numbers and you didn't want to do that. So what you could do is take your 12 and your 18, and we could write out to the side, I'm going to use a different color so we can see it, all the prime numbers that make up 12. So 12 is comprised of 4 times 3. I can break 4 down into 2 times 2. That's 4 times 3. So you should have seen this before if you've been watching the previous videos and breaking them into their prime numbers, factoring out the prime numbers. 18 is the same thing as 9 times 2. So that's 2 times 9 is 18. Instead of writing 9, I can write 3 times 3 because those are primes. Now here's what you want to look for to get this multiple. So we're gonna identify that we have 2's here. Those are the same thing. So I know I'm going to keep my 2. We have 3's here that are the same. And I should have wrote this differently because this 2 has no 1 to pair with. This 2 is going to be by 7, and this 3 has no 1 to pair with. So we're going to keep that 3. So we're going to end up with 2 times 2, which is 4, times 3 times 3, which is 9, which is 36. So we're going to take all those numbers we just took, and if they're repeating on top and bottom, we're just going to keep one of them. Right? So 3 and 3, we just kept one of them. But if they're not repeating, we're just going to bring those down and multiply. Notice that gives us the same answer. So there's 2 ways you can do it there. You can go ahead and write out the multiples if you want to, or you can employ this method here. I think this will be a little bit easier, especially if you get to numbers that you really don't want to calculate all the multiples out for. So let's do another problem. How to find the least common denominator of 2 fractions. Basically, what did we do? Let me sum it up. Factor out each denominator into its primes. List the primes, match them. So we listed them, we matched them, and we brought them down into columns. Then we multiply them out. And the least common of the denominators is the least common denominator of the fractions. So I just illustrated that for you, but those are the steps. What about this one? Find the least common denominator for these fractions. So again, you can count out 15, 30, 45, 60, and find out where they cross. Or you could just write both of those out. Let's get the multiples of 5, which is 3 times 5. That's pretty easy. And then the multiples of 24. So let's try to take out the prime numbers. We got 12 and 2. So 12 is comprised of a 3. I'm going to keep the 3's on top of each other. Times, what did I say? 4 times, 12 times 2. So 12 is 3 times 2 times 2. And what else we got? So 3 times 2 is 6. 6 times 2 is 12. We need another 2. And notice I spread them out like this because these 3's are the same. So I can just drop that right on down here. So if I was trying to pull out all my numbers, and I left this space open so the 5 can come down, and then I'm still going to multiply all my 2's. So what does that give me? 3 times 5 is 15. 15 times 2 is 30. 30 times 2 is 60. 60 times 2 is 120. So the least common denominator for these fractions would be 120. So on the bottom, they'll both have 120, and we'll get to working those here in the future. But I wanted you to see how you can do that. Now, you could have counted out all the multiples, right, like I just said. And look how much time you would have had to take, though, to get all the way to 120, especially using 15. You're going to get 15, 30, and so on. So it's easier just to take out the prime factors and bring them down in these columns. If they repeat like 3, just use it once. If they don't, just bring them down and multiply them by each other. All right, how do we create equivalent fractions using least common denominators? And that's what I showed you a minute ago, kind of got ahead of myself. The question is convert 1/4 and 1/6 to equivalent fractions with the denominator of 12. So we want 1/4 to have a denominator of 12. We know that both of these are equal. They're the same equivalent. That's why I wrote this as equal. Well, in order for them to stay equal, it has to be the same factor bigger as the bottom is as the top. And what I mean is that I'm going to ask myself, to get from 4 to 12, I need to multiply by 3. Well, in order to keep this equal, I need to multiply by the same number, which is 3. And that gives me 3 up top. So let's do that same thing for 1/6. And we still want this one to have a denominator of 12 as well. And in order to get that one, what do we need to multiply by? Hopefully you're saying 2 there. 1 times 2 is 2. So now I can see my equivalent fractions. 1/4 is equivalent to 3/12. 1/6 is the same thing as 2/12. If you divide it in the calculator and got a decimal, you're going to get the same answer for 1/4 as you would 3/12. And likewise for 1/6 and 2/12. They're the same thing, but this is just another way of looking at it so that I can handle it easier when I'm adding or subtracting fractions. So what do we do here? How do we create equivalent fractions? We found the least common denominator. For each fraction, determine the number needed to multiply to get to that least common denominator. And then we use equivalent fractions property to multiply both the numerator and the denominator that we just found. And we simplify. So those are just a summary of the steps that we did. What about this? We found earlier that it was a 120 was the least common denominator. Let's use that to write equivalent fractions now. So we got 8/15 should be equal to another fraction that has a denominator of 120. And we got 11/24, which is equal to another fraction with a denominator of 120. So in order to figure this out, we need to find out what is the factor we need to multiply by 15 to get 120. And that, just to save us some time, 15, 34, that's going to be 8. So of course we're going to take that 8 up top too. 8 times 8 is 64. So 64/120 we just found is equal to 8/15. Because all we did was multiply the top and bottom by the same number. No, this does not work with adding 8 and adding 8. You would get a completely different fraction. They would not be equivalent. It doesn't work with subtraction. Now you can make an argument that it works for division. You could divide the top and bottom because division is the same thing as multiplication. You just kind of thinking backwards. So for instance, instead of multiplying by, if I want to divide by half, dividing this by half will be the same thing. Let me make sure I'm thinking of that right. Oh, it'll be the same thing as multiplying by 2. Oh no, I didn't want to erase that. So division, you can make an argument there, but we're just going to think in factors because most of the time that's what we want to do. We want to multiply something to get to that 120. So let's go to the one on the bottom. 24 times what gives us 120? That is going to be 5. How do I know that? Just a real quick math. 24 times 10 is 240. 120 is half of 240, so I know instead of multiplying it by 10, I can multiply by half of 10, which is 5. 11 times 5 is 55. Now you don't have to do that in your head like I did. Of course, you can just multiply on a paper or calculator, whatever you're using. So here we go. Now, can 55/120 be reduced to a smaller number? I'm hoping you say yes, and we know that why, because we just found that number. You can divide 5 out again to go back and get our original numbers. So yeah, absolutely can. These are not simplified, but they are equivalent. So did we answer our question? What is meant by least common denominator? That means we want the least common multiple, or the least common multiple between those two numbers. Given a fraction, how can we find the least common denominator? Given two fractions, we can do that by pulling out those prime numbers. If you remember, we had 3 and 5, and then on the bottom we had 3, 2, and whatever those numbers are, and bringing this down to a 3 times 5 times 2 times 2. So that's how we talked about doing it. How do we create an equivalent fraction? All we do is take that fraction, and what number am I writing? We take that fraction and multiply it by whatever factor we need to. Like you can multiply, to get your new fraction. So you can multiply both sides by both top and bottom by 2, 3, whatever it is, as long as they're the same, and you'll get an equivalent fraction. Hey guys, thanks for tuning in again. My name is Brandon Clayton, and I will see you next lesson.